Okay, so we have a number 13 from AIME test. So we have a triangle AB, AC, and BC are given. And there's a point D such that AD bisect side BC and ADB is a right angle. And we want to find the ratio of two areas, basically. Okay, so the first, I'll start with drawing a diagram. So since like root 30 is larger than the other one, so AB should be a larger one. So I'll go ahead and draw something resemble illustration. So let's say this is a triangle I have. So then I'll say this is A, and then let's say this is B, and AB. So I'll say this is C. So AB is root 30, and then AC is root 6, and BC is root 30, okay, 15. But let's read the question for the location of D. It says the D is a point on AD, so A is right here, okay, and bisect to BC. So the side BC is right here. So if you have bisecting, so you're going to have the halfway through of that. So you have to go through A and then bisect BC. So let's say this is kind of AD. Okay. And ADB is a right angle. So there is a point D on like this segment, but it's not here for sure. Maybe outside, maybe inside. And then ADB is right angle. So like based on my kind of diagram, so it is going to be somewhere outside. If you think about the inside, you can try, but I think it's not the case because we use a kind of Pythagorean, so you will see that doesn't really satisfy or allow something like that. But anyway, so let's say the point D is somewhere right here. So you can go with that. And if I connect these two, okay, this is my D. And I don't know the name of this one. I'm going to call this is E. And we know the entire BC was root 15, so that should be root 15 over 2. And then root 15 over 2. Okay, so what we know is, okay, we are looking for the ADB, area of ADB, so which is this triangle, and then ABC, which is this triangle. So we know the sides of this triangle, but we don't know the D and BD. So, but at the same time, when you look at this triangle, one of the things I can easily kind of see that we may find this AE easily by using this theorem, because we have the two sides and then we have other two kind of pieces of the third side. So if I call this, let's say AE, kind of reminder like this theorem, you kind of I did a few times before, but I will say review those if you need to. But if there's a triangle and then there's a serium, it doesn't have to be angle bisector or median, anything. It's just a segment from one corner to the opposite end. So let's say this is ABC and this is D. I'm going to call this is A, B, C, and D, and I'll say this is N. So when there's a situation like this, the relation between those five segments is this: the square of N is equal to the square of A multiplied by the D, which is kind of opposite. So times D plus and square of B multiplied by the C, and then divide this by the sum of those two bottom one, which is D plus C plus D, and then subtract the product of those two. Okay, so this is one way of writing theorem, but if you've seen some other ways which are available, but I feel like this is kind of better than the other version, in my this experience. So you can use either one, but I will go with it. So with that in mind, so I'm going to use AE as my N. So in that case, like you see, AE squared will be equal to the square of this, which is 30 times this part, which is going to be root 15 over 2, plus the square of this, which is 6 times opposite, which is root 15 over 2. And if you apply this intermediate, like when C and D are equal, you can make this is going to be 2C and then this is going to be C squared. You will see a cancellation. This will be a bit simpler, but this is more general version of the median, I guess, formula. So we can just kind of use the C word for anything. And then we divide this by this sum of these two, which is C plus D. In my case, that's root 15. And then subtract the product of those two, this guy times this guy, which will be 15 over 4. So like you may kind of try to simplify and do whatever, but I see there's a really nice cancellation, and then this is a mean of that later. So like if I divide the top and bottom by root 5, so this root 5, this root 5, this root 5 will be canceling each other. So then this entire fraction will be just 30 over 2 plus 6 over 2, which is like 31 over 2. So you can just write that immediately, which I will 36 over, actually 30 plus 6, which is 36 over 2, which is 18, and then minus 15 over 4. And that will be like 76, I mean 72 over 72 minus 15, which is 57. So the AE is equal to AE squared, which is 57 over 4, and that means AE, right? So root 57 over 2. Okay, that's something. I'm gonna write here. So 57 over 2. Since we are done with that part, so I'm going to clear this part. So we just use this keyword to get what we want. Okay, now we want to find the, let's move this as well. So what we want is now is just kind of see the relation, because we want to compare the areas. We need their like side length so we can compare the areas. So I need DE. I'm gonna call this is like A and this is B. If I use the Pythagorean 2 times because they're triangle, so I will get something out of it. So let's say A squared plus B squared is going to be square root of this, which is 15 over 4. And if I use this larger one, so you get A plus root 57 over 2 squared plus B squared is equal to 30. So now we want to kind of solve the system, and then we are lucky that we can't cancel a lot of things if I subtract. So if I subtract the top from the bottom, when you expand this one, you got A squared, and then you got 2 times A times this number plus square root of this number, right? So A squared and A squared will cancel, B squared and B squared will cancel. So I will kind of write what is left over. So the middle term from here is going to be left over. So which will be 2 times A times root 57 over 2 is the middle term from here. And plus the square of the second term, which is going to be 57 over 4. And then A squared minus, like A squared and B squared will cancel, this and this will cancel, A squared and squared will cancel. So you got 30 minus 15 over 4. Okay, so then, this is going to be 120 over 4 minus 15, which is 105. So you can say this is 105 over 4. And we may cancel these and then subtract 57 from this one. Like this is like 60 to 100 is like 48, 45 plus 3 is like 47. Let me double check. So I think actually 57 because that's is it? Let me double check. Like we have 120 minus 15, which is 105, and then we do have 57. That's 60. That's 45, 48. Actually, that's 48, right? Okay, that is 48, if I'm not mistaken. So we got the 8 times root 57 is equal to whatever left from this. Let me double check. Actually, we had 30 minus this, which is 120 over 4. That's 105 over 4, which was good. And we have 57 over 4, so which is the case. And if I take the difference, that will give us like just the 105 minus 57, that's 60, that's 60, 45, 48 over 4, which is 12. Okay, so then the A has to be like 12 over root 57, which is 12 root 57 over 57, if I want to write that way. So now we have this A, which is cool. I don't need B anymore because we just need a relation. So like if you compare the area of this triangle, like let me write here. So that B, D, E, this triangle, divided by B, A, E. Since those two triangles share this vertex, so the area ratio will be a side ratio, which is going to give us A over, I'll say the BD. Okay, so like BD, I mean not BD, DE over AE. And I know that DE is like A, which is like this number. Maybe I could write 12 over root 57, which is okay, but I'm going to write 12 root 57 over 57 over AE. AE is this guy, which is root 57 over 2. So cancel these guys. So you got 12 over 57 times this 1 over 2. If you multiply this by 2, you get 24 over 57. So meaning that we can find the relation between those two areas. Like if I want to say area of like DE is like to divide by this with this 24 over 7. You may even simplify as like divide by 3, which is 8 and 19. So if I say this is A as area, so that should be 19. And that should be 19 as well, because this side and this side was equal. So we have to put ADB, which is 8 and 19, which is 27, over ABC, which is 2 of those 19, which is 38. These are already simplified. So we should add these two numbers, I guess, right? So we are going to get 50 and 65 as our answer. Okay, so I hope that was clear. So that was a number 13. And the only, I'll say the point that kind of making it a bit challenging is just maybe kind of seeing the theorem immediately. After that, like we just kind of use some equation to get this variable because we need this distance so we can compare the areas with the other one. So that was kind of tricky. But anyway, if you do need more practice on this theorem, so I will say just do it and practice on those. Okay, I'll see you in this.